Okay, this is part 2 of limiting reagent. So a lot of this is the same, but I want to work with finding volume of a gas at standard atmospheric pressure. And this kind of, the reason why I'm picking this problem is because you guys in my class, starting this year, you have you're responsible for gas stoichiometry right now, along with limiting reagent. So I figure this is a nice way to kind of blend the idea of gas, a little bit of gas stoichiometry, along with limiting reagent. Okay, so this kind of bridges everything together to make sure we're well prepared and have a pretty thorough understanding, and I hope that'll help you guys down the road. You guys in honors chemistry, hopefully this is a good review for your final exam or whatever during the school year or whatever you need. As you can see, we've evolved quite a bit. All right, so, hey, by the way, it's a great school, by the way. You may want to consider going there, you people in honors chem. Okay. All right. So before you start doing a problem without thinking the problem, don't just do the problem, think the problem. And as some of you sophomores remember, I'd say, what did I say? Don't think the problem, do the problem. I forget, yeah. Don't just do the problem, think the problem, okay? So here we go. What I like about these is, right here I've got 20 grams of this, I got 20 grams of that. So right off the bat, you're thinking, well, I have the same amount. They're all going to react fully. Well, that's BS. Like brass on the periodic table, that's BS. Ha ha ha. Okay. No, what that tells you is 20 grams of solid sodium. Sodium is an alkali metal. Sodium is crazy. Sodium has 1 valence electron, unless you lose one. So it's pretty darn active to be able to react with water, which is held by a covalent bond, has a hydrogen bond IMFs. But here's my thing. I've got 20 grams of 2 moles of an atom with a mass of 22.989. I've got 20 grams with a reaction where it requires 2 moles, right, of a substance with a molar mass of 18. So 20 and 20 only tells you part of the story. So what we want to find out is this. What is the volume of hydrogen gas, okay? Gas is given off. The volume, so the unit is liters, and we're going to assume standard atmospheric pressure. So you guys in honors chem, this should be easy for you. My guys, it should be easy for you too. So we want our final answer in liters. So here's the thing. We know that sodium comes in, breaks apart the hydrogen and oxygen atoms. Okay? So we got to find out what's limiting, sodium or water. Do I run out of sodium? Right? So a lot of this becomes water? Or do I run out of water so some of this goes back to sodium? So we got to figure out which one is limiting. That'll give you a true understanding of the problem. So let's start here. So let's start with sodium and determine, if we analyze sodium, what volume of hydrogen gas we'll get. So let's start there, 20 grams of sodium. So here we go. So part 1, find determining limiting reagent. 20 grams of sodium. You can see I still use my colored chalk, my technology. Not those goofy laptops and all other stuff y'all use up there. Okay, so here's your 20 grams of sodium. This works just fine. Saves a lot of money too. It's 20 grams of sodium, right? So now my question is, you want what unit down here? The molar mass. The molar mass of sodium is about 22.98. We'll put it up to 23. I know I don't do significant figures. But we know 1 mole of sodium is equivalent to 23 grams of molar mass of sodium. Okay, so let's now start to look into this equation. We do that using the mole ratio. So let's take a look here. How many moles are we reacting in this equation? 2. So I'm going to use the mole ratio, 2 moles of sodium, right? Now we're going to start to bridge over to hydrogen gas. How many moles do we have? 1 mole of hydrogen gas. And keep in mind we're at STP. Okay, now last part. What unit do I want down here? Oh, cancel, cancel. Moles, so I'm going to put 1 mole of H2. And we've already learned that 1 mole of a gas at standard atmospheric pressure always occupies 22.4 liters every time. And we learned that through the ideal gas law and everything else in this class. So now instead of the molar mass up here, that would give us grams. Like in the last problem, we want liters, so therefore we're going to use 22.4 liters of H2 gas. And cancel, cancel. Final answer is going to be 9.7 approximately liters of diatomic hydrogen is produced. Okay, that doesn't tell me anything yet. I have to determine what's the limiting reagent first. So we've taken care of that so far. So now let's analyze the water. So again, write down the given. 20 grams of water. What goes down here, the molar mass? The molar mass of water is going to be 18 grams per 1 mole of water. Okay, now customize it. Now we got to cite the equation. Right here we want to go real time with the equation. I want to start the bridge from here to here. How do we do that? Think mole ratio. So right down here you obviously want the unit moles. How many moles in this reaction? 2 moles. How many moles in this reaction, Roger? 1 mole. Okay? You can stop right here and figure out what the limiting reagent will be just by moles, but I want it in liters because I want to reinforce the concept of gas stoichiometry and dimensional analysis. So again, keep going. Cancel, 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 cancel. What goes down here? 1 mole of H2. What goes up top? Should be 2 grams. Up. No, you know what? I just made a mistake. I was so used to doing the molar mass, I forgot we need to find volume. So we use our given 22.4 liters of H2. Okay, so given that information, my final answer here is going to be 12.4 approximately liters of H2 is produced. So now which one limits? Which one prevents more from reacting? Which one do I run out of first so we can't form new bonds and revert? It would be sodium. So sodium is the limiting reagent. I put a little LR up there. Okay, so this guy right here is going to be in excess. Okay, so now we got to determine, now this is pretty simple, you know this, how much is left over in the beaker? How much of this reverts back? So now you want to focus on these 2 values. Now you're done with this part of the reaction. Now we need to focus on how much do we have left over. But we're not going to really calculate how much is left in excess. What are we going to calculate? How much of this reacts with that before it runs out. Again, how much of this reacts with that before it runs out, before it limits the reaction. Go figure all these words. Okay, so we start with our given again. We start off with our given of 20 grams of sodium, since that's our limiting reaction. So that's like part 1. Here's part 2. 20 grams sodium. Same problem. 1 mole of sodium is equal to 23 grams of sodium. Cancel, cancel. Boom, put it right down here. Now we got to go real time right here. Cite the equation with your mole ratio. How many moles of sodium is reacting in this specific reaction? 2. So I'm going to put 2 moles of sodium. How many moles of water are reacting in this reaction? 2. Oh, I cancel out the 1. 2 moles of H2O. Cancel, cancel. Okay, now I want to know, this is a liquid, how many grams do I have left over? But that's not going to, I'm not going to get that here. I'm going to get how much reacted. So watch. Cancel that out. Down here, what unit goes down here? 1 mole water. What goes up here? The molar mass. 18 grams. I know, sing it to yourself. You know the song. 18 grams. Final answer down here tells me 15.8 grams. 15.8 grams of H2O. Now I want you to think, again, when you compare this, if I have 20 grams in the beaker, given this information, knowing that this is the limiting reagent, by going through here, comparing them, this tells me 15.8 grams reacted. How much was left in excess? I'm sure a lot of you make this mistake and put this as excess. No, that's not right. To get the excess, I think I'm running out of room. You take 20 grams, which was the actual value in the beaker, minus the amount that was reacted, 15.8 grams, right? And your answer should be, if my math is right, 4.2 grams of what was left in excess? Water. So again, it's like sodium, crazy, right? Water breaks apart. Who do I go with? Where do I go? They formed that, but we're out of sodium. Oh no. How much of this goes? How much water goes back to the way it used to be? 4.2 grams. Okay. So there you go. I hope this helps. My guys, you have an exam. Well, for this year, it's biochem, all the stoichiometry you can ask for, every type, mobile, you name it, and everything else. Who knows in the future years what exam this will be on. And hopefully that helps you people in high school for your final exam. All right, that's it. Hope that helps.